Okay, so today we're on the back side of your 6-6 notes. There on the bottom we have our information about kites. So, a kite is a quadrilateral with two pairs of consecutive sides that are congruent and no opposite sides that are congruent. And so we end up with this situation. Again, quadrilateral, so there's four sides. Consecutive sides are congruent. Consecutive, of course, meaning right next to. Sides that are next to each other are congruent. There's two pairs of those, but opposite sides are not congruent. Okay? Because if the consecutive sides were congruent and opposite sides were congruent, we would no longer have a kite, we would have a rhombus. Okay? So, consecutive sides are congruent in such a way that opposite sides are not congruent. So that's what makes a kite. Then there is some vocab that goes along with a kite. Okay, I believe the book talks about some of this, but not all of it. So I added some notes. I added some notes to this. So first off, take the vocab that we used with isosceles triangles, and we apply it to kites. Because if I drew a diagonal in right here, you would see that this is an isosceles triangle and this is an isosceles triangle, correct? Well, in an isosceles triangle, since we have our two congruent sides, we said that in an isosceles triangle, that angle formed by the two congruent sides, which at that point we called legs, the angle formed by those two congruent sides was a vertex angle. Right? Well, guess what we call them in kites? A vertex angle. It's the same thing. The angle formed by two congruent sides is a vertex angle. And so in a kite, we have two vertex angles. Well, again, there are two other angles to talk about in a kite, and so we get real technical on how we describe those. Those are then non-vertex angles. All right, our non-vertex angles are just the angles formed by the two sides that are not congruent. Easy enough? Yeah. Okay. So that's what a kite is. Now, there is some other information here about a kite. Let's take a look at that. This was given in our book. I believe this is the only theorem given in the book for kites. We will add to it today. There's lots more to talk about with kites. But first off, if you have a quadrilateral that is a kite, so two consecutive sides that are congruent, then the diagonals are perpendicular. Okay? So that is our property for kites that the book gives us, is that the diagonals of a kite are perpendicular to each other. Well, that's wonderful. That's great. But there's more to it than that. Okay? There's more to it than that. And so off to the side here, I'm just going to draw. You guys don't have to copy this down if you don't want to. But I am going to make a kite because I simply want to show more of the properties. All right, so there's my kite. Let me mark my sides. And we know, because we were just told, that our diagonals are going to be congruent. Well, first things first, before I get to, or not diagonals congruent, excuse me, I said that wrong. The diagonals are going to be perpendicular. But before I get there, let's take a look at this diagonal. All right, so I drew in that diagonal. By the way, I described that as the vertex diagonal. Any idea why I use the fancy language of vertex diagonal for that one?
Because it goes from vertex angle to vertex.
That is exactly it. I'm not getting clever here or anything, all right? It's just, it goes from vertex angle to vertex angle, so it's the vertex diagonal. Okay? So I bet you can think of what I'm going to call the other one. The non-vertex diagonal, exactly, okay. So anyways, our vertex diagonal, take a look at that. Take a look at that. Now, don't look at this as a kite anymore. Look at it as two triangles. What can you tell me about those two triangles? They're congruent. Why? Remember?
Side, side, side.
Side, side, side. That vertex diagonal is a shared side. It's the same side for both triangles. And so these two triangles are congruent because of side, side, side. Okay, well, look what happens then. If those triangles are congruent, that means that all of their corresponding parts are also congruent. That tells me that this angle must be congruent to this angle. That tells me that this angle must be congruent to this angle. Oh, cool. What can we now call that vertex diagonal? It's not just a vertex diagonal.
It's an angle bisector.
It's also an angle bisector. Oh, cool. All right. Let's see. There's something else going on here. Something else. Because again, if we have corresponding parts, we talked about two of the angles. Why didn't we talk about the third? Well, this angle up here, because the triangles are congruent by side, 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 is going to be congruent to this angle over here. Oh, look at that. Those happen to be the non-vertex angles. And so in a kite, the non-vertex angles are going to be congruent. Cool. All right. Well, there's something else going on here. There's something else going on here. There's another property that comes from this. And by the way, everything that we're doing right now is using a property called symmetry. You guys have probably heard of it before. You guys have probably used it before. Okay. It's a topic in geometry that we aren't allowed, or we're allowed. We just don't have the time to spend a lot of time on it. Okay. But the big ideas that you need to worry about are just that symmetry is like a reflection. This type of symmetry is a reflection. There's all sorts of types of symmetry. Rotational symmetry and all sorts of stuff. Okay? But all we're saying, think of it back to like grade school when you guys used to cut hearts out of red and pink construction paper at Valentine's Day, right? You take the construction paper, fold it in half, draw half a heart, cut it out. When you unfold it, oh look, it's a full heart, right?
Right.
Right. That was symmetry. That's all you need to know. Okay? That is symmetry. And so, going along with that idea of symmetry, and there's other things we could talk about here, but if I look at this diagonal now, okay, and that is now being called my non-vertex diagonal because it's connecting the non-vertex angles. Looking at the top here, what type of triangle is that on top? Isosceles. And so my base angles would be congruent. My two sides here are congruent. But notice that I have this segment drawn from the vertex angle, and it happens to be an angle bisector, right? Okay, we had a theorem about that in first semester. It's not in this packet of notes. It was theorem, I believe we called it 415. That was the theorem that said that if a segment drawn from the vertex angle of an isosceles triangle is either an angle bisector, or a median, or an altitude, if it's any one of the three, it's all three. Well, we now know that, hey, that happens to be an angle bisector, therefore it's an altitude. That's how I would prove the theorem that they gave us in the book. My diagonals are perpendicular. But it's also a median, meaning that these two segments have to be congruent to each other. That gives us another property for kites. And the other property now is that that vertex diagonal bisects the non-vertex diagonal. Okay? In a kite, the vertex diagonal will bisect the non-vertex diagonal. Okay, so let's go ahead and write these down. Coming back up here, you can find some place to put them. I'll just list them right below our previous theorem here. So we obviously know, because it's given in the book, that the diagonals are perpendicular to each other. But we then have three more properties that we'd like to list, because they're handy to know. Okay, and one of them is that the vertex diagonal is an angle bisector. We also know that the vertex diagonal bisects the non-vertex diagonal. And the last property that we talked about was that the non-vertex angles are congruent. Okay, so along with the definition of a kite, which says that it has two sets of consecutive congruent sides where opposite sides are not congruent, we also have 4 additional properties. The diagonals are perpendicular. The vertex diagonal is an angle bisector. The vertex diagonal bisects the non-vertex diagonal. And the non-vertex angles are congruent. Questions on how or why any of these are true in a kite? So let's take a look at a couple of quick examples. So for our first example here, finding angle measures in kites, it tells us that we have a quadrilateral DEFG and it's a kite. We want to know what the angles 1, 2, and 3 measure. So first off, looking at this kite, I want you to identify which sides are congruent. Okay, they don't have it marked, but it's drawn in such a way that we should be able to tell pretty easily which segments are congruent. Okay, so which segments of our kite, which sides of the kite are congruent? Yeah. EF and GF, excellent. Then DE must be congruent to DG, absolutely. Okay? I like to have that marked so that I can very easily identify vertex angles, non-vertex angles, and of course the vertex and non-vertex diagonals. Okay? So now that I know that, there should be 2 angles that I can immediately say the answer for. Somebody name one of them.
Number 1 is 90 degrees.
Angle 1 is
90 degrees.
90 degrees. The measure of angle 1 is 90 degrees because we know the diagonals of a kite are perpendicular. What's the other one that we can immediately say the answer for? Yes, ma'am. Angle which one? No. Angle 3 is 52 degrees. The measure of angle 3 is 52 degrees because the vertex diagonal right here bisects the vertex angles. Okay, and so of course this is a vertex angle there. If this one's 52 degrees, this one must be 52 degrees. Okay? And we have one more to find, which is angle 2. There are multiple ways of finding angle 2, but probably the easiest way and quickest is to go ahead and look at that small triangle right there. We already know the 90-degree angle. We already know the 52-degree angle. Therefore, I already heard angle 2 is 38 degrees. Absolutely. Measure of angle 2 is 38 degrees. Questions? Let's try it again. Next example. Which one do we immediately know? Measure of angle 1 is 90 degrees. What other one do we immediately know? Measure of angle 3 is 36 degrees. Okay, so then to find the measure of angle 2, just like before, we should look at this triangle here, this small triangle. There are other ways of finding angle 2, But again, this is probably the quickest and easiest. So looking at that small triangle, we know we have a 90-degree angle there. We know we have a 36-degree angle there. That means angle 2 must measure what? 54 degrees. Very good. Any questions? No. Okay.